Hi, the lecture today is going to be about the derivatives. In the previous lectures we have learned about the concept of slope and its application in a variety of fields. Now we essentially go ahead and introduce a notation and a common terminology for all these cases. So we really don't have any new ideas to talk about in this section, just a matter of notation. So we had that slope of tangent line to graph of y equal to f of x at point where x is equal to a is the limit of f of a plus h minus f of a over h as h goes to 0. Now instead of that long title, or instead of gearing ourselves to pictures and geometry and that kind of application, we just go and introduce a word and a notation so that we just move ourselves away from that particular application. We are going to call this the derivative of the function f at a, and we are going to write it by using the name of the function, whatever the name was. So if this is f, this is going to be f. We are going to put a prime notation on top of it, so there's a prime notation. We are going to indicate the location at which we are going to calculate the derivative f prime of a, and we are going to write it just as that limit f of a plus h minus f of a divided by h as h goes to 0. So this is the derivative of y is equal to f of x at x equal to a. So how do you read this? You read it f prime at a. So or f prime of a so we are already done with half of our lecture for today. Really don't have much to say. Then next idea, we said that if you want to write the equation of a line, equation of a line through points say a and b with slope m. That's from college algebra. You remember how to write the equation of a line. So y minus the y of a given point is equal to slope times x minus the x of a given point. Question here is, how about the equation of the tangent line? Well, for the tangent line, so here's the issue. If I have one function and some point on it, and I want to write the equation of this tangent line, well, I'll have my x coordinate, that is a. Remember, the function was f of x, so its y coordinate here is f of a. This point is a point with coordinates a and f of a. You have to get used to that the height of a point on a graph is just f of a. Now how about the slope of this? Slope of this line, that is just a derivative. M is equal to f prime of a. So one thing we learned in the lecture today is that the slope is also going to be written in this fashion, f prime of a. So what's the equation of a line then? Then I have to write y minus y of a given point here is the y of the given point. It's f of a is equal to slope. What's the slope of the tangent line? Well, it's f prime of a times x, a of the point, just a of point. So this is the equation of tangent line to y equal to f of x at x is equal to a. Many problems, when they give you, they say at, they give you both x and y, but then you can, that's a redundant information. You can find y on your own if a function is given to you. So let's remember this. In many applications, a is given to you as a number, as a known number. Every now and then it might not be given to you as a known number. Just remember not to mix that with this. Use a different letter to indicate the point at which you are creating tangent line, that's this point. Differentiate that from x. X is coordinate of some point on this line. In this equation, x and y, coordinates of some points on this line. A and f of a, this is happening at the point of tangency. That point, you have one point in common between the line and the curve. So one common mistake students make is they use the letter x here, but that's not going to work because x means something else. So long as you use two different letters, you will be fine. Now, we mentioned that derivatives are used, well, we talked about slope first. We mentioned that slope is used in many other areas of science. So by now, we know that all those applications are examples of derivative. So we have, for example, velocity, which was a rate of change of position with respect to time. So let's quickly go over some of the applications. First, remember these words, all of them mean the same thing: slope, rate, grade, pitch, gradient, tilt. More or less they mean the same thing. Now we are adding to this list, we are adding this important word. We are calling all of these guys examples of derivative. So previous application of rate, for example, we looked at the rate of change of one quantity with respect to another. So for example, when I have y is equal to some function of t, and t indicates time for me, and y indicates position, then if I go ahead and calculate f prime of a, in that context, it's going to mean the rate of change of position with respect to time at time equal to some given value, say a. So that was the meaning of velocity at time a. In the same sense, you can talk about acceleration. Acceleration is a rate of change of velocity with respect to time. Later on in your physics classes, you are going to learn about current, like electric current. Electric currents are rate of change of electric charge with respect to time. Later on in this course, we are going to talk about the linear density of various material. We're going to talk about that. That's going to be rate of change of mass with respect to position. We are going to talk about marginal cost as an application in business. We're going to have marginal cost, marginal profit, marginal revenue. These are all rate of change of that quantity, but rate of change of cost with respect to number of items produced, and so on. And then we are going to have all sorts of other relative rates of change to be introduced to you. So there are at least a dozen applications of this concept that you are going to see in this course, in some or other courses. So it's an extremely important concept. It has to be understood precisely and carefully, and also you should be able to handle the algebra that is related to it. So that's going to be a foundation for all sorts of things you are going to go ahead and do. So since the lecture was so short today, I'll just go ahead and do some examples. Here are examples to consider. So examples. We are going to concentrate on the algebra component, and then you go ahead and read about all the other applications and such in the text itself. So here is a good application, a good example. I might pick this one. F of x is equal to, say, x squared plus 2 over, say, x minus 1. Question is find f prime of a. Okay, so we are all over with the concepts, philosophy and all of that. Now the main thing is just going through the algebra, making sure you get everything right. It's a very good practice for you to brush up on your algebra and also increase your speed. One entity you need in calculus is how fast you do your algebra. Slow handling of these algebraic steps is going to create problems later on, and so you want to do so many of these problems so that you can do each of them in a couple of minutes. So what is involved here? Since we are going to be taking two steps, one is to make that quotient, and after that is all cleaned up, we want to apply the limit process. In order not to write this thing so many times without using it, first you might as well want to write that component. When you're all done, at the last step you come and introduce your limit operation. So I'm going to use that kind of writing now, because amount of writing might be too much, and as much abbreviation we introduce is going to be helpful. So here is the difference quotient itself. Difference quotient is f of a plus h minus f of a divided by h. So I'm not taking limits yet. What should I do? Well, that is going to be make room for it here. Remember, this is idea of substitution, has to be done carefully. So here's your x. That x is showing up on the right hand side like that. Now instead of that x, I have to go ahead and put this a plus h. So wherever I see that red thing, I'm going to put this blue thing now. That's all. So if we go ahead and continue, I write is equal to, putting this up here, I'll have a plus h squared plus 2 over a plus h minus 1. Putting it in parentheses is a good idea so that you see you have done the copying right. Minus a squared plus 2 over a minus 1. So I just put this red item here instead of this blue item instead of red ones. That's piece number 1. Then just a copy of this. Instead of x, I'm using a, just a copy. Denominator is just an h. So we are already to have 50% of this, understanding what the difference quotient itself is. Next comes the litmus test. Can you go ahead and clean up this fraction? Okay, so that's going to require all the mastery you gain in high school with handling all sort of nasty expressions. Is going to be one more of these. So what do we do? This being the first time, I write down all the steps. Later on, we are going to bypass some of these. We have to multiply these two items to get the common denominator. So this parenthesis, I don't need it anymore. A plus h minus 1 times a minus 1. That's the common denominator. Now, how do you actually subtract the two fractions? Remember, you are multiplying this and that with a minus 1. Maybe I have to write it all out. We are really multiplying a minus 1 over a minus 1 with this fraction to make the denominator of this have elements present in the denominator of this one. And also we have to take this one and multiply with the denominator of this fraction, which is a plus h minus 1 over a plus h minus 1. I am not intending to confuse you. If you learn to do this some other way in high school, just go ahead and do it. Just be careful in all of your steps. So we went ahead, made the two denominators to be the same. Now the numerator is going to be this numerator times this denominator. So I go ahead and write that now. Most likely we are going to run out of room here. A minus 1 times this one is a plus h squared plus 2 minus, because of this minus, and then the other item is a squared plus 2 times this quantity, which is a plus h minus 1. Thankfully we could squeeze everything here, divided by h. Now I go ahead, I learned my lessons, go all the way to the left. Things to do: to combine this denominator with that denominator, make one common denominator. Second item, we have to multiply these things, so we get ready for that. I have denominator and h, a plus h minus 1 and a minus 1. Here I have a minus 1 times the second item. Should square this quickly. A squared plus 2ah plus h squared plus 2 minus second one. There isn't anything to do. We could have multiplied if we wanted to. Now I go ahead and multiply. How do we multiply one parenthesis with another one? You notice that the notion of foiling is no longer applicable. That was good for high school. You might as well leave it at the gateway of university once you go in a university. So how do you multiply a here? You take the first item, you multiply by every element in the second parenthesis. Next round, you'll take the second item, multiply by everything in the second parenthesis. And if you add more, you just continue doing that. So here I take a, multiply by everything. Let's see, anticipating that we might run out of room, so I am gonna try to squeeze everything up here. So I'll have a times a squared is a cubed, a times 2ah, 2a squared h, a h squared plus 2a. Now I have to multiply minus by all of these, so minus a squared minus 2ah minus h squared minus 2. Now I have to subtract this from that. I could write it here, but just to see everything on one line, I go ahead and continue this. Here I write minus a squared times a, it's a cubed. Let me put everything in parentheses, that will be safer. So I write minus a times everything, and then I bring my subtraction inside later on. A squared times h, a squared times minus 1. Now 2 times a, 2 times h, 2 times minus 1. Denominator, I still have h times a plus h minus 1 times a minus 1. Now I might go ahead and do the subtraction and simplification from that. You can just go ahead and subtract it, or you might go ahead and simplify first. Either way is fine. How do we simplify? Here, for example, I say it's a cubed and a cubed. Other things that right away cancel out. A squared and a squared cancel out. 2a and 2a cancel out. This 2 and this 2 cancel out. The other ones, we have a squared h here and another a squared h here. We might as well go ahead and combine them, see what we have. A squared h, 2 of them here minus 1 of them here, that's going to make a squared h. So I have by now taken care of these two. Now I have other elements to write. I write a h squared, so I took care of that. I have minus 2ah. I wrote that one also. Then I have minus h squared and minus 2ah minus 2h, and that I have accounted for everything in the numerator, I believe, if I haven't missed anything. Denominator, I just have h times a plus h minus 1 times a minus 1. In the act of differentiation, one major item is deletion of an h, cancellation of h from numerator and denominator. Here we don't have a difficult task because you just have a h that you can factor. H times a squared plus ah minus 2 minus h minus 2 over h times a plus h minus 1 times a minus 1. And of course now what happens is that the main activity of cancelling an h is now done. So remember, we started with this difference quotient, simplified, and we brought it all the way to that simple form. What is it that we need to do at the very end? At the very end, after you have simplified this difference quotient, after this is all done, you need to take your limit to calculate your f prime. So here I write f prime of a is the limit of, so now I made a mistake myself. I better, this is a separate stage, so I comma a big comma there. We are changing gear. We are taking limit now. F prime of a is equal to limit of this one, a squared plus ah minus 2a minus 2 over a plus h minus 1 times a minus 1, h going 0. So we saved on writing this thing about a dozen times all over here. We really didn't need it, so we introduce it just at the end when it kicks in. F prime of a, when h goes to 0, of course these are the things that drop out, and you are left with, in the numerator, a squared minus 2a minus 2. Denominator, you're left with a minus 1 times another a minus 1, which squares it. Okay, so that was the answer to this problem. And then now we get ready for another problem to do. Okay, for the next problem, maybe I do something with a radical. We have, this is a good example. Let's see, f of x is equal to, say, radical 5x plus 2. And the question is, find f prime of a. Okay, so we start, we learn, we start with the difference quotient, the average rate of change. What should I do? Well, first, instead of this x, that red one, I'm going to substitute this blue one. So I'll have radical 5 times, okay, instead of x, that's where substitution happens, a plus h. So my suggestion is that in your function you go ahead, put your variable in a parentheses so that you see clearly what the substitution is going to be. You literally replace that with this one. That's all you do. So there's no room for mistake there. Now f of a, instead of x, you're just putting a divided by h. Okay, we have seen this situation about a dozen times so far. You're handling difference of radicals. You use the product or conjugate's identity to get rid of the radicals in this place, but at the cost of making it show up somewhere else. So 5 times, I might open this one as well, 5a plus 5h minus or plus 2 minus radical 5a plus 2 divided by h. I take this, multiply by term that is just really 1, but it is made out of the conjugate, 5a plus 5h plus 2 plus radical 5a plus 2, and divided by the same thing, 5a plus 5h plus 2 plus radical 5a plus 2. That is, well, we multiply the numerators. We might as well make it a little bit more presentable by wrapping them up in parentheses. Now, first times first makes the radical go away, so I'll have 5a plus 5h minus plus 2. This radical times that one makes the radical go away. I am careful about my parentheses. If I make a mistake on that, the whole problem is going to break down. H times radical first 5a plus 5h plus 2, and the second 5a plus 2. Well, time for cancellation. 5a and 5a, 2 and 2. We are learning to be a little bit faster and not write so much. So all these things gone. I have a h and 5h here, so learning to be fast. We go through that step here as well. I have 5 over 5a plus 5h plus 2 plus radical 5a plus 2. Okay, I'm done with the cancellation. So this h and that h at the very last step got cancelled out. At the beginning you couldn't do that. Now time to write the derivative. So f prime is the limit of this expression 5 over radical 5a plus 5h plus 2 plus another 5a plus 2. What is the limit? Well, this is the item that goes towards 0. That makes this radical will be a copy of that radical. So you're just doubling up on these radicals. You have 5 over 2 of these things. So I'll write 2 over radical 5a plus 2. That is our answer. Okay, I suppose you can go ahead and do a few more exercises from this section. Make sure you do so many of them so that any of these differentiations you can do under 5 minutes. Later on, by the end of this chapter 2, you should make sure you finish any of these problems under 3 minutes. Okay, good luck and God bless.